examples. So let us start with example 1. Example 1 says differentiate the following. A, differentiate the following. So the solution would be for A. For A we are given y equals to x to power 4. Okay? Which we can compare to the original assumed function. What is A? A is the coefficient of x power 4 in this case. So the coefficient of x here is 1. What is n? N is the whole power. N is the whole power of x, which is 4. Okay? Now let us see how we can differentiate this. So we are going to say we are differentiating y. So we say dy with respect to which variable x? Here we have the variable x. So we say dy dx. This means that we are differentiating the function y with respect to one of its variables x equals to. Now we say that we are going to lower the whole power, which is 4 here, lower it. So if we lower 4, remember here we have 1. We have an original 1 there. That is coefficient of x power 4 is 1. So we shall say that 1 times the whole power which we are dropping here, so that it becomes a coefficient which is 4. So 1 times 4. Okay? And then we say x. Now we are not going to write 4 here, but we are going to get a new power of x. A new power of x. How do we get the new power of x? We say it is the whole power minus 1. So the whole power was existing there as 4, but we shall subtract away 1. And then we simplify. What is 1 times 4? It is 4. X. What is 4 minus 1? It is 3. It is 3. So this is the derivative of the function y equals to x power 4. This is the answer. We have differentiated the function y with respect to its variable x. Now, that is the answer for part A. Instead, we shall apply the same concept in part B. Part B, we have y equals to 3x squared. What do? We shall say differentiating y with respect to x. Therefore, gives us dy dx equals to, we have 3 here. This 3 here corresponds to a. Okay? So we shall just say that 3, which is a, times we drop the power of x. We drop the power of x 2. And 2 corresponds to n. 2 corresponds to n. So we drop that 2. So that we say 3 times 2. Then we say x. Now we need a new power of x, which becomes the whole power, which was 2, subtract 1. And then you simplify. 3 times 2, we shall have 6. X power 2 minus 1 is 1. X power 1 is the same as x, so here we shall have 6x. So this is the derivative of the function y equals to 3x squared. So we have differentiated that function. Now part C, which is the last part of example 1, says that we are given the function y equals to 3x power 4 plus x cubed. What do we do here? If you look at this now, we have 2 terms. This is the first term, this is the second term. But in example 1, we had just a single term, also this one was a single term in part B. How do we differentiate this? Now, we are going to say differentiating function y with respect to its variable x. So dy dx becomes, we apply the same laws, okay? Term at a time. We apply the same laws, but term at a time. So in the first case, we shall consider this term, and then after we shall go and consider the second term. Now, we are going to say we have here 3 already, which corresponds to A. So we shall just say 3 times, you lower the power, which is 4. So 3 times 4. And then you attach x. Now we need a new power of x here, which becomes the old power, which was 4, minus 1. That there will give us the new power. So we have differentiated this term. Okay, we have differentiated this term. And then you continue. Here it is plus. So we say plus. Then we come and differentiate the next term, which is x cubed, independently. So if you look at this term, x cubed, the first thing that you notice here is that the coefficient here is what? Is 1. So we shall just say 1 times, we drop that power. So 1 times 3. Then you attach x. Now we need a new power on x. So how do we get the new power? It is simply the old power, which is 3, minus 1. Minus 1. So if you have 2 or more terms, you differentiate each term independently, applying the same laws on every term. So then we simplify. What is 3 times 4? It is 12. X. What is 4 minus 1? 3. So x cubed plus. What is 1 times 3? It is 3. X. What is 3 minus 1? It is 2. X squared. So this is the derivative of the function in part C. So we have differentiated that function in part C. So when we are using method 1, where we consider powers and coefficients, this is basically what we apply. And we apply it on every term that we encounter. So this is the solution to example 1.